Alright, welcome back to the channel. Today I'm going to film this a little bit different. I'm going to try this like vlog style, and I'm going to walk around a little bit. I'm going to show you some stuff. I apologize. I know I promised in my last video that I would have an update of the VFD build within like 2 weeks, I think I said, and at the time I said my son had just been born and he was home and happy. I actually edited that video and uploaded it from the NICU, from the hospital. It turned out we had some health scares and some complications with him. In the current global climate, being in a hospital, I'll just tell you, is miserable. So a good part of the last month I spent dealing with that. And then of course, this is upstate New York, so it's fairly temperate as far as the weather goes. And in a week when we were having 100-degree weather, my central air conditioning decided to die on me. So I had to deal with all of that, and 2 young kids in the house and a dog and my wife and me in very, very hot, humid upstate New York. So a lot has been going on. I apologize, but the time is here. So I have turned down, I finished all the custom work that I had planned, and for the next 2 weeks I've told people that I'm going to dedicate exclusively to the mill upgrade. So if you're here to watch that, then the next couple weeks should be pretty exciting. I don't know that they'll all get uploaded in the next week and a half or 2, but they'll certainly all get completed. It just, I'm not very good at editing videos, so it's going to take me a bit to learn that. I did film a video 2 days ago that's actually going to go up after this one. I'll give you a little spoiler of what it is, but in that I did talk about, I picked up a lav mic, so we'll see if that helps with the audio at all, and I'm going to try my best not to use the word as much as possible. In 2 videos ago, I think I said like 40 times in a 10-minute video, and a viewer commented on that. So totally justified, man. I apologize for not being very articulate, but enough of that. So I told you I'd give you a spoiler. This is going to be the content of the next video. That is an M-LOK Duo, so M-LOK 125 Duo 2-station vise. And that is part of the next video. The other parts are this incredible Saunders Machine Works fixture plate, and I actually picked up 2 of those M-LOK Duo vices. They are incredible. They nailed it. So you'll have a full video of seeing what those are like. So we'll go over a basic layout that I plan to do. I'm recording this one on my cell phone here, so if it's a little wobbly, apologize, but this is a little easier. So everything is, I'll say, mock wired up right now. So we have power coming in right here. This will be 220 volt single phase. This is 6-4 wire, so I have a red here that I'm not using because this is single phase coming in. So I'll have the 2 live 120 volt wires each, and then the ground, that's going to go to a ground lug that's going to live in here. That's again just mocked up right now, so it's not going to just be sitting there floating. It's going to be mounted to the panel. So 220 volts is going to come in, go through the 60 amp fuse block, come back into the electromagnetic contactor. So this side of the contactor will always be live. I'm going to use T1 and T2, L1 and L2 going in. This does have positions for a 3rd live wire that I could break contact with using this contactor that I don't need. So I'll have live power over here, and then only when this 24 volt power supply is turned on will the the load side of this contactor be live. So once I turn on, sorry, that's just mocked up because it's going to sit on the front of the cabinet right about there. Once I have the 24 volt power supply turned on, it's going to do, well, really 3 things. It's going to shut the electromagnetic contactor, which is going to provide power to 2 things. First, and obviously, the VFD. So the VFD will start up. Second, I haven't ran these yet, but I decided to send the 220 volts to these 3 ammeters from the load side of this electromagnetic contactor. This way they're not just always on, they would only be on if I had the 24 volt power supply on. That's going to be the only external indication on this enclosure that I plan on building, so that'll actually be helpful. It'll tell me whether or not that contactor is shut and I have 220 volt single phase applied to the VFD, just with a really quick glance over if these are lit up and working. So it'll do those two things. It'll turn the ammeters on, the VFD on, and then a third thing, it'll supply power to that 24 volt power supply, or sorry, 24 volt fan. So the fan will turn on, the VFD will turn on, and the ammeters will turn on, all when this 24 volt power supply gets power. All these components are going to be mounted to some sections of DIN rail. I haven't chopped those or put them in their final resting place yet, but I will. So power is going to come in. It's going to go through the electromagnetic contactor into, I guess I can take these covers off so you can see a little bit better. Okay. It's going to go into L1 and L2 here. That's positive, or sorry, that's hot voltage. So that'll be the two 120 volts, giving me 240 volts right here. The ground cable will go to the common ground right there. So then I have the line side over here, and then that is going to go into the VFD, convert to three-phase 240 volts at a variable frequency, which will obviously give me my speed control, and then I have my three live three-phase lines coming out, which are black, white, and red, and then the ground that's going to go to the motor is in green. So over here on the right, this is 3 of those ferrite cores. I have each phase triple wound going through the ferrite core. They all enter the same way, are wrapped in the same direction, and then leave. So that's the proper way to use these 3 ferrite cores. I could have done 4, I could have done 1, I could have done 2. I just decided on 3 pretty arbitrarily. So we'll see if that's enough to get rid of EMI. If not, I can always add more, and too many is not a big deal. Then right after the ferrite cores, I have the inductive ammeters. So those are going to come off one off of each phase. So you can see I have this red indication off the red line. There's no rhyme or reason for these colors or why I picked one over the other, but these are going to be output on the side of the enclosure right here. So they'll actually face this direction and be mounted to the enclosure. And then power is going to leave the top, or potentially even this, I guess it would be the left-hand side there, because this is how I'm going to be facing the case. Probably leave the left-hand side so it can go to the motor itself up to the mill spindle. So the fan is going to blow air into the case right against the side of the VFD. This VFD has its own fan, like I mentioned as well, so that's going to have air circulation. And then the exit of the airflow is going to come out of a screened grate, which is going to be on the front panel right about here. So that's going to force all of the air to move out in this direction, flow past these components, and then come out. Again, that fan will give some additional circulation, and that should be enough ventilation for this enclosure. If not, I can always add a second fan or a couple more openings or something like that. But that's the general layout that we're going to go with for now. I am going to try first and foremost getting that ground properly mounted. I'm going to lay out the location for all the holes so I can mount the DIN plates as well as mount the VFD, which does have to be directly screwed to the subplate. Mount all of that first, give this a final coat of paint, because this is just some primer, some self-etching primer, and then mount everything, get it firmly mounted but not in the enclosure, and then we're going to try to fire up this VFD. Here we go. I just did an overlay on the left. That's from the MS300 manual. That's the wiring diagram, and I just showed you roughly where the locations of each of those components are. From there, once I had it mocked up, I put it inside the enclosure so I could decide where the penetrations were going to go. Basically, in my mind, I laid out where the wires would go through and which places I needed to make cuts, and then I marked it all off with either Sharpie or, like you see here, some painter's tape. Tried to get them as straight as possible and try to cut inside the lines with the Dremel tool that I used. I did use a respirator because cutting this fiberglass makes a lot of dust and I don't really want to breathe that in. I didn't have a 0.86 6-inch drill, so I just drilled it to a 1/2 inch for these ammeters, and then used the Dremel to widen those holes, and they came out pretty perfect. You can see in a second here, once the ammeters are installed, you can barely even tell that, I mean, you can't tell that there's any missteps or gaps around them. So that's true with a lot of these components. On the air exhaust in this cabinet, that was really my worst. So this, what you're looking at here, if you look at that from the inside, which you'll see in a couple pictures, there is a bit of a uneven hole, but that's okay because from the outside you'll never notice. And same over here on the left hand side of the enclosure. So looking inside, you can see on the door that's not a perfect cutout. It's perfectly good enough for what I need for air to get out of the enclosure, and you can see the fan is mounted in there. And now I'm just going to show you a bit of the, I'll call it the final product. I haven't routed the wires through, but that's it after all the cuts and the components are mounted on the outside of it. So all the wire glands are on there, and I'll show you the other side here in a second. This will be what I see from where I'm standing in the mill. I'm going to face that right hand side. And then I wired up the motor. I didn't go in depth, it wasn't worth it. There's a couple wire nuts, and I labeled each of those wires to make sure that I connected the leads to the right place, and if I did happen to get it backwards and the motor spun backwards, it was easy to swap any two of those leads. If you dislike rework, the grommets that attach the cables to the case have to go on first before you put anything that would prohibit a pass-through, like ferrites, which I'm about to put on these, as well as, sorry, it's a bit of a mess in here, these inductive current meters or ammeters. So what I have to do here, order of operations, is going to be put the nut on first, get it all the way onto the wire. Once it's down there, it can just stay there. Then run it through the case so that the loose ends are through the case. Put the other half of the wire nut on, at least thread it through, it doesn't need to be tightened. And then with all the wire pulled through the case, you can go ahead and do anything you want. And then at the end, tighten it up and figure out your final location. If you don't do that, then you're going to have a great time taking it all back apart, putting it back together again. Ask me how I know. The VFD is completely wired up, so I have the 3 phases coming out and then leaving the left-hand side. I'll do a bit of a walk around of the enclosure in a second. I have power coming in on the bottom left here, so all of the cables come in and leave on this left-hand side. You can see I have 2 spots that are empty right down there. One of those is going to be for the control, and then another one I'll just block off for now. I just don't want to have to drill into it in the future if I need to make an expansion or add something to it. And then I have my ferrites stuck right here. Those are triple wrapped. Like I said, I would kind of arbitrarily decide 3 wraps of each wire is what fit through the ferrites, and I have 3 stacked on there. So that should work pretty well. I have the cores right there for the ammeters, the 3 ammeters, and I think that is everything. So it should be good to wire up. Right now I have power, so this is input power coming in, and it's just dead-ended right here for now. So I have ground and then my 220 volt lines, which will give me my 240 volts going in, and that's going to get hooked up to a double pole 60 amp breaker. So this is nothing special. I did verify that the wires would fit in there, and I have a ground lug in my control cabinet that will fit one of those 6 or number 6 wire gauge. So I think I'm ready to go. I have to run to Home Depot real quick. I don't have, so the knockouts in my electrical cabinet, I don't have anything that'll fit a large enough one to get that. It's about a 1-inch outside diameter for the 6-4 wire that I'm running on the input, so I don't have anything large enough to go through the knockout and retain it. So I have to go get something from Home Depot real quick, and then once that's done, I'll wire it up and it should be ready to go. So hopefully you'll see me in a second and we will do some spindle running. As you can see, I'm in different clothes. This is a different day than I first started filming this. It probably took me 2.5 days. Not 2.5 days of work, but 2.5 actual days to get this all done, because life happens and I have kids and a family. So on the left hand side here, so that's going to be the air intake that I talked about. You have load side, line side, and then in the bottom there, that's the 120 volts going in to give me power to the fan as well as power to the contactor to shut the contactor. I can actually plug it in right now and you could hear the fan kick on. So open it up. You're not going to see anything exciting, which is a good thing, I hope. All right. So plugged in. There, that click you heard was the contactor shutting. Not going to reach my hands in here because there is live 120 volts in the case right now. Nothing is actually exposed, something I forgot to mention. So nothing, I designed it so that there is no exposed conduit anywhere. I don't know that I really designed it that way. It's how electrical cabinets typically go, but I made sure that there was no conductors that I could physically reach inside of here. So although I wouldn't call it touch safe, I wouldn't reach around in there, because if you did manage to touch the actual screw posts on that 120 volt power supply or the 24 volt power supply, it does have power. So not that I'm going to be fishing around in here, but to reach in and touch the buttons on the top of the VFD, everything up here is safe. Again, I say that with bated breath a little bit. These three ammeters on the back right here do have 240 volts on them, only when 240 volts is present. So you can see they're off right now because I talked about this in the beginning. I wired them on the load side of this contactor, so there'll be 240 volts supplying them whenever that contactor is shut. So the same time the VFD gets power, those will turn on. So enough comfortable room that I can get in here and touch these buttons without actually reaching near it. I may, in the beginning, just lay some rubber sheeting around here while I work, just because I am going to be reaching in and out of there. I also thought about in the future, so this control panel right there comes off. They sell adapters where you can plug in sort of like an extension cord. I was thinking about potentially mounting that over here, and then I would always have external control of the VFD. That's probably a good idea, and I'll most likely do it. But for now, we'll see how this works. So my breaker box right there is where it goes in. It's this top 60 amp breaker. Right now it's labeled water pump because that's what I stole from my mill originally. So we've got 240 coming into here. I do have the 120 plugged in, so you'll see it is on. I did just turn it on real quick to make sure nothing blew up before I started filming. So you see the displays read 0 amps, and got a little tachometer here. I put a piece of reflective tape on there. I have not hit the run button yet, so let's do it together. I blow up, you guys will see it with me, so wish me luck. This should work fine, I'm not super worried. I am, however, worried about that motor wobbling. So it should be pretty well balanced. That's a cast iron V-sheave on it that I purchased from a reputable manufacturer, so it should be pretty well balanced. I have it set at, well, it's at 60 hertz because that's how it started up. I'm just gonna go for it. I'll keep my finger on the stop button and hit run, and if it starts wobbling or I'm not comfortable, I'll slow it down or stop it. But see what happens. So if I hit this green run button, we should start seeing current and the motor should turn on. Wish me luck. Yeah, buddy. Oh yeah. All right, and there it is. Let's see what we're reading for current. We have just over 5 amps. 5.1. The motor is spinning in the right direction, and let's see if we can grab a reading. See if I can get over here. Should be, sorry, see how I can do this. Should be 1800 RPM at 60 hertz. If that's not beautiful, I don't know what is. it dropping off is because I'm missing the reflective tape. 1800 RPM. That is beautiful. We have a 3-phase motor in the house. Still humming along at 5 amps. I don't know how much higher than nominal speed I want to crank this up without it bolted to anything, but oh no, that's right. So this up button should raise frequency. Oh, it probably comes pre-configured to limit to 60 hertz, so let's try slowing it down, I guess. So I'm just gonna hold. Oh yeah. I guess let's check the speed. So go to 30. Now let's see if it runs at 900 RPM. 33. Trying to get the hang of this. Alright, so we are at 30 hertz. Definitely running slower. Let's see if it's running at 900 RPM. Oh, come on, that is beautiful. This is gonna work great. Alright, hit the stop button. So I'm gonna watch current here. We're still at 5 amps. Watch it after I hit stop. So here I go. There's stop. And there we go. Cold to the touch. That fan blows a lot of air. Awesome. I am excited. That'll work beautifully. Alright, so I think that's going to do it. I just played around with the settings a little bit, so I have it all kind of buttoned up here now. I unfortunately have to get going for the night, but I changed a few settings. I went through the manual. It's an exhaustive list of things that you have to go through on this, but I wrote down some settings I wanted to change and mess with that a little bit. I guess I'll just tell you what I changed. So I changed it to sensorless vector control mode, so that's going to work a little bit better than the velocity mode that it was in. Hopefully it'll give me some more torque and the motor will run a bit better as a spindle motor. I set the max frequency to 157 hertz. That is the calculated speed that is going to give me 11,000 RPM on the spindle based off the pulley ratio and the motor base speed, which is 1800 RPM. So at 157 hertz, I think that, let me do a little quick math. So 120 would be 3600. That's like 4100 RPM that the motor would have to spin to. It's rated at 5000 or 5400, I think, RPM. So it's within the range, but I'll get back to that in a second. And then I changed the acceleration and deceleration time. They were set to 10 seconds, so at 60 hertz, it would take 10 seconds for the motor to get to 60 hertz, and then 10 seconds to decelerate from 60 hertz. So and it's scaled. So if you tried to run at 120 hertz or double the speed that the base is, it would take 20 seconds to get up to speed and then 20 seconds to slow back down, which is just way too much for me, so for a spindle motor. So I set those values to 3 just as a sort of starting point, and I can play around with it from there. I did end up having the VFD trip on an overload once. Excuse me. I tried to run the motor at 120 hertz, and so that would have been 3600 RPM. The big cast iron pulley that I have here, I think might just be, I'm going to have to check the rating on this and what speed that's good to and what speed that's balanced to. I really just wasn't happy with the sound of it. Sort of sounded like a jet engine taking off. So with it not mounted to anything and sort of me being in the line of fire for shrapnel if that were to explode, not that I think that would happen, I decided to turn it off so it was still coming up to speed. And I cut it out a bit early, and because it was in the middle of accelerating and I told it to decelerate at those new quicker rates, it tripped on an overload. So I'm gonna have to kind of play with that, and I think once I get it mounted up onto the mill, I will try it again and see what frequency it sounds acceptable and do some testing. I'm going to call the manufacturer of that pulley and see what they rate it at and what they would be okay with. Obviously the motor would handle it plenty fine, so I just chickened out a little bit. Maybe we'll try it again next time. It would be unfortunate if I only got I had it at 3,000 RPM running fine, and I was perfectly happy with it, but with my pulley ratio, that only gives me like 7,000 RPM on the spindle. I was really hoping for 10 or 11,000, so it's still more than double what I have now, and I would be very happy with 7,000 RPM. If it got to the point where I was limited to 7,000 RPM, I would probably do probably do a bit of a redesign and get rid of the 7-inch V-sheave that's on there. The only reason I went with such a large pulley on the motor is so I could get the highest reduction possible, and I could get it wouldn't really be a reduction, the highest increase as possible on the spindle speed. So the larger the drive pulley compared to the driven pulley obviously gives you a faster speed on the spindle side. So if I'm limited to 7,000 RPM, I'll probably drop that pulley down to like a 5-inch pulley, just so it has less rotating mass and it'll make the motor last a little bit longer, I think. So I don't know. Sorry, I'm just rambling now a bit. But overall, big success. The motor is up, it's running. I now have to tear it back down and at least take the power cord out of the circuit breaker box so that I can get the mill up and running again. And I think the next project is going to be sort of debating it. So the plan for those motor or the shocks that are going to mount the air shocks, I'm going to have to make some sort of mounting bracket to position them back there, and I will probably do that next. I'm going to make those out of steel. Sorry if it's a bit dark over here. This is my random metal box. I have plenty of big hunks of steel that should serve the purpose. I was going to do the spindle pulley next, and that's going to be made out of aluminum, but I sort of want to get all the steel parts out of the way so that I can set the mill up and run some mist coolant. It gets it pretty sticky and nasty in there, so I try to do all my aluminum cutting at the same time if possible, because I have OCD and I like to start with the machine pretty clean and end with it pretty clean. So I think the next is going to be those 2 steel brackets that'll mount the air struts to displace the weight on the head, and then from there probably the V-sheaves or the V-sheave, and then that's almost it. I have to mount or machine the head spacer, and that's like a 1 operation, maybe, or 2 operation, like maybe half-hour part total. So all of the aluminum parts may end up being in 1 video, and then from there we're done with the machine. Rip it down, fill it with epoxy granite, get all the upgrades installed, redo the spindle, and then see if it works. It's really my biggest worry, is that I put all this time and money into it, and then I start something back up and there's a catastrophic failure, or my spindle has 4 thousandths a run out or something like that. So I don't know. We'll watch me in my journey and see if this all works out. Thanks for stopping by. See you in the next one.